Hello everyone, I am Irene May Pilar. This day we are going to demonstrate about the reflection of waves. First, let's find out what happened to the traveling waves through the string gets reflected at a fixed point. We settle the string with a fixed end, and as you can see, the waves that travels down a loop gets reflected at the
It will
root's end.
travel through the loop towards the right end of the medium. Poles is called the incident poles, since it is incident towards the boundary with the pole. When the incident poles reaches the boundary, the two things occur. First is the reflected poles, in which it is the portion of the energy carried by the poles is reflected and returned towards the left end of the loop. Second, causes the pole to vibrate is the portion of energy carried by the poles is transmitted to the pole. The reflected pulse is inverted. The incident and reflected pulses have the same wavelength. Every particle within the loop will have the same frequency. Being connected to one another, they must vibrate at the same frequency, since the wavelength of the wave depends upon the frequency and the speed. Two waves have the same frequency at the same speed must also have the same wavelength.
Next, we are going to demonstrate a wave of a string with a lost end. When a crest reaches the end of the loop, the last particle of the loop receives the same upward displacement. Only now, there is no adjoining particle to pull downward upon the last particle of the loop to cause it to be inverted.
The result is that the reflected pulse is not inverted. When an upward displaced pulse is incident upon a free end, it returns as an upward displaced pulse after reflection. Inversion is not observed in free end reflection.